Hi everybody, this is a video I am making for my Social Work 110 classes, and it is a video that accompanies the Canvas page entitled Chi-Square. It is intended to go along with the same fact pattern and the operations that I teach you how to do on the Canvas page, and it's just more reinforcement for what I'm hoping you're able to learn. So what I have in front of me now is the fact pattern that I use on that page and the blank table that you find, well, and it's one of them, on your participation sheet for week 8. And what I'm going to do right now is walk through the fact pattern and teach you how to set up the observed values. So this video is making an assumption, and the assumption is that you've already read the Canvas page that I've posted for this week. If you've already done that, this is all going to make a lot more sense because, again, this is simply just an attempt to reinforce what I've already been teaching through that page. So, again, if you haven't read that Canvas page yet, it's a great idea to stop the video and read it first because this is probably going to make a lot more sense if you do. I'm going to go ahead and assume you all have. Those of you who are watching now, in the Canvas page, I give you a fact pattern, and this is the exact same fact pattern. A social worker wants to understand if an association exists between job satisfaction and level of social work education. To conduct this research, she surveyed 30 social workers in the field with either BSW or MSW as their highest level of education. Besides level of education, she asked whether they are satisfied in their current position. Of those identifying at the BSW level, 6 stated they are satisfied at their current job, while 11 elected the unsatisfied category. For those identifying the MSW level, 10 stated they are satisfied, and 3 indicated they are unsatisfied. So the first thing to remember is that anytime you're given a new fact pattern, you have the opportunity to recognize a new null hypothesis. In this particular case, we're looking at 2 variables, job satisfaction and level of social work education. And if we were constructing this as a null hypothesis, the key words you're always going to start with are there is no. Okay, so again, a null is always going to say no. Okay, there is no. Okay, you could say relationship or you could say association. In this case, I'm going to say association between, now we have to talk about the 2 variables, okay, level of social work education and job satisfaction. Okay, so again, I have a constructed null hypothesis here, and this is what we're going to be operating on throughout the exercise, okay? And we're going to determine at the end whether or not we're going to accept or reject this. So there's no association between level of social work education and job satisfaction. To set up the observed values on your contingency table or cross tabulation, whenever you're given a new fact pattern, you can go ahead and put your observed values right in, okay? In this particular case, we know, and again, it doesn't matter whether the variables whether the variables at the top or the side, they're interchangeable. In this particular case, I'm going to assume that this particular variable that sits on top is going to be the job satisfaction. So there were 2 choices or attributes here: satisfied, okay, or unsatisfied, okay, and we're going to have a total. And we're also, for the level of social work education, going to have the variable that sits on the left-hand side, and we know it's going to be BSW and also MSW, and then the total will go at the bottom. Okay, and when we look at the variables here, okay, those who reported being BSWs and satisfied with their job were 6 of them. BSWs unsatisfied were 11. Okay, you can find that in the facts right here, 6 and 11, for a grand total of 17. And for the MSWs, we had satisfied equaling 10 and we had the unsatisfied equaling 3 for a total of 13. So now we can start to put in the totals. 16, okay, 6 plus 10 is 16. Unsatisfied, 11 and 3 is 14. And the total is 30. And again, this is also the n value, so we should say n equals 30. And you can see that the 17 plus 13 is 30, and the 16 and 14 is 30. So pretty basic here. That's how you set this up. I'm going to go ahead and in the next segment talk about how you set up the expected values. Now that you have the observed values completed, then I went ahead and made the writing a little larger. I boldfaced some things so it's a little clearer for you. Now that we have the observed values, now we can go ahead and create the cross tabulation for the expected values. Now that's a little bit harder, just simply because we're not just simply looking at numbers and applying them as we did here with the observed values. We're actually going to have to do some calculations. So the best way to do this, and if you're looking at your participation sheet, we're now moving from the cross tabulation on your left-hand side, which you use to fill out the observed values. We're moving over to the one on the right-hand side, okay? So I'm just doing, the reason I'm not doing that on this is because I need the space to kind of work, but if you can have your participation sheet in front of you, on the right-hand side of side 2 for participation sheet week 8, on the right-hand side is for your expected values. And the easiest way to create the expected values chart, and I'm going to just go ahead and drop it in here in a moment, is for you to recreate what you found on your observed values, but leave out these 4 cells right here. So you have the 6, the 11, the 3, and the 10. You would recreate this particular cross tabulation, but you would do so without the expected, without those values for the 4 middle cells. And it looks something like this. There it is. Ta-da. Okay, it's magic. So actually it's just cut and paste. But nonetheless, what we have here is the expected values. And I've gone ahead and changed the title from observed values to expected values. And what we do is we have these 4 cells in the middle cleared so that we can do the calculations. Each cell, and I left some space down here for me to use to show you, is going to be handled in the same way I'm about to do this one. So if you want to find the expected value for any cell, what you need to do is you first need to multiply the values of the totals at the edges. What does that mean? Well, you can see this cell right here is at the intersection of BSW and satisfied. That's where we're at right there. Okay, so if we're looking for the expected value for this cell, the first thing we want to do is go down and find this value. It's 16. So I'm going to write 16 right here. We're going to multiply that times 17 right here because that's the other n total. The n totals are 16 and 17. That's how you know. So for this cell, 16, 17. Okay, 16 times 17 equals. And just because we want to be extra sure about everything we're doing today, we're just going to go 16 times 17 equals 272. So we'll go ahead and knock that down and we'll say 272. Okay, now that's not all, because in order to find this value, you're going to have to divide what you found, or the product here, by the n. So 272, okay, we'll go down to one more. 272 divided by 30. What does that equal? Well, again, we just want to be extra sure today. So we're just going to come back to our calculator and go 272 divided by 30, and that equals what for us? Well, it's got 906666666, oh, so on and so forth. We're just going to go out 2 decimal places, so we're going to round it up. So 6 carried over, rounding up that hundredths place, is going to be 9.067, since 6 is greater than 5 here. So I'm just going to put 9.07 as my answer. Okay, 9.07. There it is. So that's going to be the expected value, okay, for this particular cell. Now, can you imagine if I showed you what we did here like that, and I said, you're going to do the same thing on this one. Do you know what to do next? Well, all you have to do is follow the previous steps. for this particular cell, which is at the intersection of BSW and unsatisfied, so it's this cell, our first value is going to be 14, because that's at the end. See 14 right there, okay? And 17, okay? So 14 times 17 is going to give us, I guess I can clean that up a little bit, 14 times 17 is going to give us a total. And again, we'll just go ahead and use our calculator, because the calculator is going to be a little more infallible than a human brain. Hate to say that, but okay, it's going to give us a total of 238. So the product here is 238. I'll just knock that down. 238. Okay, so then 238 divided by what? Well, divided by n. And it's the same thing we did here. Okay, 272 divided by 30, and 30 is the n. Okay, 238 divided by n. What does n equal? 30. Okay, there we go. So we'll bring the calculator back up, and we'll say 238 divided by 30. Okay. It gives us 7.9333333. Well, since the third digit out is under 5, we'll just keep it at 7.93 because we're rounding. So we'll go equals, okay, 7.93. Okay. And I will go ahead and highlight it just because. Okay. Now, this is probably getting easier. I'll go do this one next because I usually do it like a clock. There you go, or around like that. Okay, so with respect to this cell, okay, we'll go ahead and say, what's this one? What's the expected value for this cell? Well, we look down to the 14. I'll put that down there. Times, what's the other column's total? Okay, 13, 14 times 13. Okay, equals, we'll go ahead and come back to our calculator, clear it out. Okay, 14 times 13, and what's that equal? Okay, 182. So we'll go ahead and say 182, and then we bring it down, 182 divided by n, which in this case n is 30, like as it has been the last couple. That hasn't changed at all, has it? Okay, so we'll go ahead and just be very consistent here and bring our calculator back up, 182 divided by 30. Okay, 6.066666, or 6.07, okay? So we'll just say 6.07, and I'll just boldface this, okay? I'll boldface that for you, okay? And the final cell that we're going to be looking at, you know this, by now it should be routine, okay? To find the expected value at the intersection of MSW and satisfied, okay? This area right here, we're going to take the 16 times, what's the end here? 13, that's the end total, okay? And what's that going to give us? Well, let's just go ahead and do it then. 16 times 13, okay, 16 times 13 equals 208, okay? 16 times 13 is 208. So we're going to go down one, 208 divided by 30, okay? And what's that going to give us? Let's find this out, okay? 208 divided by 30, 6.9333333. Of course, we've seen this before. 6.93 is what we'll stop at. Okay. Actually, I'll go ahead and do this. 6.93. There it is. So go ahead and highlight that. Okay. And so at the end, once you are completely done, if you just take out all the math, then here's what you're left with. Okay. You're left with all of the expected values for each of these cells. Okay. So the way to think of this is now we have the observed values and the expected values. And on the next segment, I'm going to show you what to do once you have the observed values and the expected values to find the calculated value overall for the chi-square you are using. So for this segment, I'm going to walk us through how to find the calculated value for our chi-square once we have the observed and the expected values completed. So the formula I'm going to show you right now is also the one you saw in the Canvas page for this same topic for guided practice. But I'm just going to reiterate it here, and I'm going to do it very slowly. So whenever you see an x squared, that symbol is for chi-squared. The Greek symbol for chi is actually an x. So chi-squared, and then we have a shorthand for the formula here, sigma, of course the sum of, observed value, so that's up here, the observed values are right here, okay, minus the expected values, okay, squared, so the difference between these is squared, divided by the expected value. So on this segment of this video, I'm going to walk you through how to do that. It's not nearly as hard as it looks. You just have to be very patient with your work and patient with yourself. And I think I'm going to go ahead and get started here. So you're going to find a calculated value for each one of the cells. So just like we had an observed value for here and a corresponding expected value here, we're going to use both of these values to find a calculated value for this cell. Because notice the cell for BSW is satisfied, okay, right there and right there. Okay, it's almost like they're over top of each other. So we're going to find a value that's the total value or the total calculated value for that cell. So how do we do that? Well, it's actually not too hard. We're going to let's just start with this cell right here. We'll just call this the BSW/satisfied cell. Sometimes I call this the A cell because it's the one I begin with. So I'll go ahead and just do that today. I'll just go A, okay, here's the A cell. And how we do it is we follow our formula right here, okay? We take the observed value, which is 6, okay, and we subtract from it the expected value, which is 9.07, so 9.07, okay? And we got to notice that this is actually in parentheses, and it's also going to be squared, so I'll go ahead and just so we know exactly what we're doing here, I'll go ahead and hit that squared key to remind us what we're doing. So let's just go ahead and see what we have here, okay? So we're going to go ahead and say, okay, that 6 minus 9.07, well, what could that possibly be? I think I know, but we'll do it anyway. 6 minus 9.07, okay? And that's going to give us negative 3.07. So we'll just say this for the fun of it here is negative 3.07. And again, the important thing to remember is that that is a value that we're going to square. And the reason why that's important is because just like when we were doing this with the standard deviations, okay, we're trying to get rid of this negative number. We're trying to get this nice and clean, right? Okay. So what we want to do then is we want to square that number, and we'll just do that by coming up here again. Here's our calculator, and I'm just going to go ahead and square it. There's the square key right there. Okay, 9.4249. Well, I'm just going to use this digit right here and its relationship to the hundredths place. So the only thing I'm worried about is 9.42. Since this is under 5, I'm not going to move this up to a 3. Okay, so 9.42. So equals 9.42, okay? But then look, okay, once we found the difference and squared it, we need to divide it by the expected value again. What did we say the expected value was? It was 9.07. So I'm just going to go 9.07, okay? So it's this value right here again. So in our formula, observed minus expected squared. We did that right here. Okay, we took the observed, right there, 6, minus the expected, 9.07. We found that it was negative 3.07. We squared it. That gave us 9.42. And we're going to divide it by the expected again. So we're dividing by that same value. Okay. And when we do that, what's it going to be? Okay. Well, I'm going to go ahead and make it clean. 9.42 divided by 9.07. And what's that give us? Okay. It gives us a bigger number, right? 1.03, but then there's an 8 next to it, so I'll just move that over here. 1.04 is what we'll say once we've rounded up to the hundredths place, okay? 1.04. Okay, what does this tell us? It tells us that for the calculated value for this cell, which again corresponds up here and right here, okay, the calculated value for this cell, the BSW and satisfied, regardless of what we're looking at, is going to be 1.04, okay? So now let's go ahead and come down. First of all, I'll turn the boldface off, and I'll go to the B cell. I usually call the second one over the B cell, okay? So we'll go ahead and say, what's the observed? See, again, following our formula, okay, observed minus expected. Okay, the observed is 11. And for the corresponding cell, okay, of the expected, it's 7.93. So we'll go 11 minus 7.93. Okay, and once again, we know that that is going to be squared. So I'll just make sure that I note that to myself, squared. Okay, and then we'll go here. All right. So using our calculator, again, just get in the habit of it, okay? We'll just say 11 minus 7.93 is going to give us 3.07, okay? Well, that looks familiar, doesn't it? That's what we found before. This is not uncommon with chi-square. You start to see a lot of repeating values. And remember, if we're doing squared as a function of the formula, the algebraic formula, then we have to do it with all of them. So even though this isn't negative, we still are going to square everything. So we're going to have equal treatment here. Okay, so we're going to come over here like that, and we're going to go like that again, just to get that off. Okay, and then, well, I got news for you. Since negative 3.07 is squared is 9.42, it's going to be the same regardless of whether it's negative. So 9.42. Only this time we're going to divide it by, okay, the expected value, which is 7.93. Again, here's our expected values. For this cell, it's 7.93. So 7.93, okay? And if we do that, then what do we do? What do we find here? Okay, then it's 9.42 divided by 7.93. For a total of 1.187, and we can round that up to 1.19, okay, since this is above 5. So 1.19. And I'll just go ahead and boldface it so we remember what we're looking at here. Just makes it a little brighter for us. Okay, so then we're going to go down to what I call cell C. Again, I like to go in a clockwise fashion. So we want A, B, and C. It's right here. So I'm going to come down here to C. C is already there. Okay, so here's our C. The observed value here, because remember we're going with observed. It's O. Okay, there's our observed values. Here's 3. So 3 minus. And what is the expected value here? 6.07. Okay. And will that be squared? Yes, it will be. Glad you asked. Okay. So we're going to go squared, and then we're going to turn that function off so we don't get more things with subscripts. And then we're going to go ahead and figure out what that is. Okay. And we'll do that by using our calculator. 3 minus 6.07 equals, okay, how about that? Does that look familiar to you? Okay, 3.07. Okay, and because we know it needs to be squared, I'll go ahead and do that for you now. Okay, okay, there it is. Okay, and equals, well, remember what it was before? I got news for you, it hasn't changed. It's the same, only the thing that has changed is the expected value. The expected value here for this particular cell, okay, is 6.07. So 6.07. Okay. And what we're going to find here is with the calculator. I want to get you in the habit of this. Okay, 9.42 divided by 6.07. What's that going to give us? 1.55, and we can just round to 1.55, okay? Right now you're probably getting the hang of this, which is really the goal here.
not supposed to be tricky. It's not supposed to be difficult. We're just supposed to just go through it and find the answers. And I think you're going to be satisfied at the end that you know how to do this. For the D cell, which is this one corresponding with this one, okay, the observed value is 10. So we'll go 10 right here, minus expected value here is 6.93. There we go. Yep. Hey, did I forget something? Hey, don't forget that. It's not what you want to forget. All right, squared. So now we're going to come over here. And when we do the math, again with our calculator, it's going to be 10 minus 6.93. I guess you can't guess what we're going to have here, do you? Oh, did you know it was going to be 3.07? Okay, that's good. 3.07. Okay, just so we're absolutely crystal clear about what we're doing. Go ahead and square that. Okay, and then we're going to move down here. And so what I'm going to do here is, just as you expect me to do, I'm going to write 9.42 divided by, what's the expected value here? 6.93. 6.93. We're going to find out what that equals. Okay. So again, say 9.42 divided by 6.93. And that's going to give us 1.36. 1.36. Do you see how I got that? 9 raised, when I rounded, the 9 raised the 5 up to a 6. Okay, 1.36. So what have we done in this video segment? We have found, once you have the observed values and the expected values, how to find the calculated values. These are all the calculated values, but there is one more step that we need to make sure that we don't forget. Okay, so for this particular part, okay, I'm going to go just give it to you in this notation. Okay, we're going to say that the chi-squared, okay, calculated value. Make sure that I'm not using everything in subscript. Okay, calculated. Okay, is going to equal, look what we had up here. Let's not forget this. Okay, the sum of everything here. So we got 1.04 plus 1.19 plus 1.55 plus 1.36. So let's just go ahead and do that. 1.04 plus 1.19. Whoops, 1.19. Okay, don't need more decimals than we need. Okay. 1.55, okay, and finally 1.36. What's this going to give us? Well, let's go ahead, and what I'm going to do, just because I'm particular about it, is I'll just go ahead and make these look very consistent, even though they probably don't need to. I'm just going to make them kind of stand out for you so they can easier on your eyes maybe. Okay, so now what are we going to do? Well, we want to be exacting here. So I'm going to clear out my calculator, and I'm going to say 1.04 plus 1.19 plus 1.55 plus 1.36 for a grand total of 5.14. So that is going to be, okay, once I knock this down, okay, 5.14 is going to be our calculated value in total for our particular chi-square application for this fact pattern. So, they're not always going to be the same. Fact patterns are going to change, observed values are going to change, and therefore expected values are going to change. So naturally then chi-square calculated values are going to change depending on your fact pattern. So what we've done so far now is walk through how to how to create the null hypothesis, how to set up a cross-tabulation with observed values, how to calculate and set up a cross-tabulation with expected values, and how to find, using both sets of values, observed and expected, the chi-square calculated value. Okay, be proud of yourselves. Okay, this is a lot of work, but you're getting through it all right. Now we're going to go ahead and move on to figure out what we need to do next with the chi-squared calculated value and how to compare it to the critical value. Okay, everybody, so for this last video segment, what I'm going to do first is walk you through how to find a critical value, and then I'm going to help you figure out what to do once you found the critical value and make a comparison between the critical and the calculated value, ultimately to interpret your chi-square. So we're going to start with this step right here. So everything above here is what we've already done. And beginning right here where my cursor is, right here, we're going to go ahead and consider what to do next. We have the calculated value. It's right here. Okay. Now we need to find the critical value, which these steps will lead up to. So how do you find the critical value for a chi-square? Well, a little bit's going to have to do with what your chi-square contingency table or cross tabulation looks like. If you were to turn to page 69 of your text, you're going to find a chart that looks loosely like the one I'm about to show you. Okay, this one right here. Now this is a little different than the one in your text, but it's the same idea. So what you're going to have on the left-hand side is a column called degrees of freedom. It's also represented on in your text by a little DF in italics, but really DF is just shorthand for degrees of freedom. And what you're going to want to do is you're going to want to, just like we did with the normal distribution percentages, you're going to go ahead and follow down and find one of these degrees of freedom. And I'm going to show you how and what it takes to find that. So let's go back to our paper. And the way to figure out what degree, let's do it this way, degrees of freedom. The way to determine that for any chi-square is to find basically use this equation. Number of rows or columns, you can do it either way, number of rows or columns minus 1. You're going to multiply that times number of columns minus 1. It doesn't matter what order it is. I could have just as easily have put number of columns over here and number of rows over here. You're going to end up with the same number. So here's how I think this is where students get confused. Okay, the number of rows. Well, you might be going 1, 2, 3, 4. And actually, that's not right, because what we're not counting are the titles and also the totals. The titles and totals are not included here. So let's take a look at this. Would we do anything up here? No, we're not including that. So here's one row, because it's got values. Okay, here's one row right here. And then we have another row right here. So there's 2 rows. Are we doing the totals? No. Titles and totals are not included here. So we're going to say number of rows. How many did we have here? We have 2, minus 1, because that's part of the formula. Okay, minus 1. Oops. I'll go ahead and take it this way. Minus 1 times, and then let's see how many columns we have. So we'll have the number of columns right here. Well, remember that titles and totals don't count. So, okay, we have 1, 2. So we'll go 2 minus 1. Well, last time I checked, 2 minus 1 is 1. So 2 minus 1, okay, equals 1 times 2 minus 1, okay, equals 1 again. So 1 times 1 equals 1. Okay, this was not that difficult, was it? Let me bring that back. Okay, so now we're going to go over to our picture. And so I put my finger or cursor right here. And how many degrees of freedom are we looking at here? Well, just we're moving it down a very short distance to 1. Now, as you suspect, we're going to move across the row, but where do we stop? You know, do you remember last week when we talked about the APA format, basically stating that in terms of level of significance or confidence interval, the default position is 0.05. And do we have that up here? Ah, there it is, 0.05. So we know we're at 1 degree of freedom. Okay, we already found that out. Now we're just going to keep moving over like we did with the normal distribution percentages. 3.84. Okay, so 3.84. Let me go back to my paper now. Okay, so the critical value for this, I'm going to give myself a little bit of space here. Why don't we do that? Critical value is going to be 3.84. Okay, so now here's my question. Okay, I'm going to go ahead and highlight this or boldface it for you just so we can let it stand out. Our calculated value is 5.14. Our critical value is 3.84. So if we're to compare these, we would say that 5.14, which is the critical value, is greater than 3.84. Okay. Well, if that's the case, then we find that the critical value is greater than the calculated value is greater than the critical value in this case. So if that is the way it is, then we have to ask ourselves this in terms of interpretation. Okay, if the calculated value is greater than the critical value, okay, we're going to reject the null hypothesis. If we had had a fact pattern where the critical value had been higher than or greater than the calculated value, we would have done the opposite. So because, I'm going to say it to you this way, because calculated value is greater, oops, I'll spell it the English, not the British way, is greater than the critical value, we shall reject, oops, look at that. If I'm putting something in all caps, you know it's serious. It's like shouting. Okay, we shall reject the null hypothesis. Okay, I'll even italicize it just to make it more louder, I guess. Okay, so why don't we do this? So now, if that's the case, then let's refresh our memory. What was the null hypothesis anyway? Well, we'll just come down here and see if we recall it. Okay, I'm going to go ahead and print it out for you. Okay, there is no association, you could have said relationship, between level of social work education and job satisfaction. Well, we decided because the calculated value is greater than the critical that we're going to reject this. So if we're rejecting the null hypothesis, and the null hypothesis is saying there is no association and we're rejecting it, then what is our ultimate finding? There is a relationship or association between level of social work education and job satisfaction. Now, just to be perfectly clear with you, if we had a scenario, okay, where we had a, let's say that these were opposites. Let's just say that it happened that the calculated value was 3.84 and the critical value was 5.14. Okay, we would have said because the critical value is greater than the calculated value, calculated value, okay, we shall accept the null hypothesis. So if our fact pattern had come out differently, we would have had this scenario where we would have had an acceptance of the null hypothesis. So instead of rejecting it, okay, we would have accepted it. We would have said, okay, yeah, we agree with this. This is true. There is no association or relationship between level of social work education and job satisfaction. So that would have been an alternative universe. We're not there under the facts that we were presented with in this case. The prevailing argument is this one. Because our calculated value was in fact greater than our critical value, we will reject the null hypothesis and find that a relationship does exist between our two variables, in this case, level of social work education and job satisfaction. Well, I know this isn't exactly the easiest thing, but hopefully it was at least clear in terms of the process. I think it's going to take a few minutes for you, or a couple attempts or swings at it, but I think you'll get it. It's just a matter of remembering the steps and practicing them, okay? Don't forget then, I'm going to also give you an independent practice problem, which I'm going to put on a Canvas page. And I'll hope that all of you get that done before we meet as a class. And look forward to hearing from you about your experience. Thanks so much.